All right, let's do a review. Exercise 2A is reviewing the things that you would have learned in primary school and last year. So reviewing angles. Here we go. Let's fill it in. Angles that are between 0 and 90 degrees is called what? Let's go with Amon. Good. Acute angles. So acute, if we started off with a line, so that's where 0 is. That's where 0 is. If I rotate anything less than 90 degrees, like that, so I rotated and I'm pointing that direction now, that's called an acute angle. Then we do, well, what if I started off with a line starting at 0 and I rotate exactly 90 degrees? So I rotate and it's exactly 90 degrees. What is this called? Can I please have Zave? It is called a right angle. Very good. Next one, angles that are between 90 degrees and 180 degrees. So again, same thing, starting off with 0. And I'm going to rotate past the 90 degree point, but less than the 180 degree point. What is this called? Let's go with, yes, Harley?
Obtuse.
Obtuse. Very good. This is called obtuse. Okay, so we can see anything more than 90 now. So starting here, I rotate to 90, then I pass 90, but still less than 180. That's called obtuse. And then when it's exactly 180, Aaron? Straight angle. Very good. So straight angle starting off at 0, and then you're obviously facing the opposite direction. So it's a 180 turn. Okay, so doing the exact opposite. Then you go angles that are between 180 to 360 degrees. So once you pass the straight line, anywhere in the second half or semicircle, what is that called, Amira? Reflex. Very good. And then finally, when you actually make a full circle, this is called, Treya? Revolution. Revolution. So full revolution or revolution. Cool. So that there is part of your learning map where it should say identify angles. Most of you have ticked that off. If I didn't tick it off, it means I wasn't sure if you actually knew that. Okay. So make sure to check your learning map here and there. If you think you already know that, let me know. Come and let me test you. But the other two, I think students tend to forget the two. The other class had some reminders. What do you call when you add angles together, specifically two angles together, and it equals exactly 90? What do we call that? Starts with C. William. Complementary. Not complete. Complementary. Not compliment. Compliment with an I means that I'm praising you, giving you sort of flattering comments. So that's compliment. But this is complet. The other one's complete. What about pairs of angles that add up to exactly 180 degrees, starting with S for this one? Hands up if you know. Oh, William again. Supplementary. Very good. This is called supplementary. So supplementary is 180. Complementary is 90. And then finally, the last one, which kind of links into tomorrow's lesson for parallel lines. But this one, these two angles are the same. So if this was 150, this one is also 150, but we'll give it a special name. What are these two angles called? Starting with V, Losalia. Very good. Vertically opposite. Vertically opposite. And what you see in that box there is pretty much your year 7 and primary school knowledge. That's the prerequisite when you come into year 8. Year 8 content is actually 2B. 2B is more about parallel lines, which is what I taught the other class today. This is what you must know to come in. Yeah? And if you don't know it, that's what you're building on. You're building on that skill. So let's do some examples so you get a feel, and then I'll show you the question that a lot of students in the other class had troubles reading. So here we go. Example 1. Let's have a look at this problem here. So you're going to have to identify the type of angles you see to be able to solve. Now, most students are able to tell me that A must equal to what here? Can I please have, let's go with, yes, Rory? Yuri? 50. Now, the question is why? So I know that intuitively a lot of students know it's 50, and there's a lot of ways to get there, but I want to know the why. What did potentially Yori did?
Well, he figured out it was a right angle, and a right angle has 90 degrees, and he figured out that if that equals 40 degrees, this must equal 50.
Very good. So one way of thinking about it is this is a right angled box. Okay, so that symbol there means 90 degrees if you didn't know. If from here to here is 90, and notice that on the bottom, they've already given you a nice straight line. This is a huge straight line. And you told me that a straight line has 180 degrees. So if this is 90, this side has to add up to 90 as well. But if this side has to add up to 90 and this is 40, then obviously you know it's 50. But the actual calculations for it, I want you to write it as A plus 40 is meant to equal 90, so it's complementary. And therefore A must equal to, now how did you know it was 50? It was 90 subtract 40. The difference between it, that's how you know it's 50. Can you see how I'm laying it out? I laid out what I did. So this step, you know that I know it's 90 degrees. And then I calculated to get there. I didn't do it intuitively. I did it mathematically. Yeah? So in your exercise, as you're doing these questions from chapter 2, you must copy the diagram and then show some working. Why? Because in 6 months' time, what I don't want to see is something like this. So if you looked at that in 6 months' time, you would have no idea what was equal to 50. You don't know what diagram you had. You don't know what it was that you identified. This one, very different. You drew a diagram. You had some working out. You would be able to work backwards. Okay, so that's the benefit of your layout now, saves your revision later. Most students leave their revision later, and that's when they do the whole entire chapter. That's why they're very bad at studying. That's why they're bad at revising. That's why they do poor on their test. That's just habits. So if you build your habits now, as you're doing your work, you write it out clear and logically. It also saves you time in revision later on. Yes? I say 6 months' time because when you get to year 9, you start doing mid-year exams. At year 7 and 8, you guys don't do it. But year 9s, they do mid-year exams for the first time. So in June, where your semester reports come in, they do an exam. And then end of year, they also do another exam. So what happens to those year 9s after year 7 and 8 is that if they built poor habits in mathematics, they get to the end of year and they get like maybe a week or 2 backs to revise. And you think about how many topics would you covered. You would have covered about 4 to 5 chapters. And you think about them, they're going through their exercise book. They're like, I don't know what I did. That's only if they did homework. And then they'll go, all right, let's go back to the textbook. And they're flicking through and they're like, oh my God. You know, I studied 2 hours, but 2 hours is not going to cover what you've done for 6 months. And that's why the kids who continually do poorly from the start of the year continually do poorly in the test, even when they try to study in the 2 weeks. So we find consistently that students who do well are usually the organized ones and also the ones who lay out their thinking. So when they revise, it's actually a lot quicker. You do a glance, you kind of rebrief your memory, and then therefore when you walk into the exam, you actually perform just as similar as how you did in your work. That's the difference between strong students and consistent students versus unorganized students and usually forgetful students in mathematics. That's how it works. Okay? So hence I'm trying to get you to build your habits there. So please do try to do question method answer. I know it takes a long time, but that's how I do it, and that's how every senior students will do it. You will eventually have to do it too. Okay? And then part B, we've got A, we found it was 50, and B must be what? Can I please have? Let's go with Elijah. What's B equal to? So in this one, B degrees, what would this have to be? Good, and what is your reasoning? Beautiful, that's all I needed. So just having some understanding. So this one is clearly complementary. So you knew it added up to 90. This one is clearly a straight angle. B is clearly a straight line. It's a semicircle there. It has to be 180 degrees. But that helps you remind yourself, I know what I did. I know how I got there. It's mathematical and logical. Okay? Let's try the next one. Same idea. So I don't want to see any of that. I don't want to see 2A, A equals 50, and B equals 180. Most students will write that. I promise you, if you find another year 8 student from another maths class, not in my class, check their book. Promise you'll see something like that. 2A, A equals 50, B equals 180. But you watch what happens, let's say in the next 2 years. I promise you, if you keep track of what I'm saying, 2 years from now, check their scores and then check your scores. There will be a huge gap. There will be a huge difference because of that small habit change you do. Yeah.
A equals 180 so it makes it 125.
Very good. So William's answering part B over here. He's saying A is equal to 125. And what did you do in between to get there?
180 minus 55.
Good. A equals 180 minus 55. So we knew that 55 plus A So 55. You guys are following here. So from here to here is 55 plus this one. That's a straight angle. That's a straight line right now. So this straight line has to add up to 180. So 55 plus A is 180. How do I find A? It's the missing amount. So 180 subtract 55 gives me 125, and that tells me A. Okay. And then how did you do for B? Beautiful. There's two ways to do it. You could also do another straight line. So now that you know A is 125, you could do 180 take away 125, or the smarter way, which is what William has done, that's vertically opposite. Okay, so if that's 55, this must be 55 as well, because they're vertically opposite to one another. Yeah? So B is 55, you can say vertically opposite. Or you can say 180 take away 125. Doesn't matter how, you just got to choose your route and then prove it. Okay? Flip over the page. So that was pretty nice and easy. That's the kind of skills you're practicing 2A. Flip over. All right, 2A question 7. So this time I've got A degrees, A degrees, A degrees. I don't know what A is, but I know they're equivalent. So 3 of them make up this arc. How do I solve this? Losalia.
Since some straight line equals to 180, you have to divide by 3 to 60.
Very good. So this is A plus A plus A. See, that makes a 180 turn. So I started over here, I rotated A, rotated another A, and then I rotated another A. I end up exactly opposite. So it's 180 degrees. So how do you set up your problem? You'd say, well, I know that A plus A plus A had to equal to 180 because it's a straight line. But since they're all the same amounts, I've got 3 equal parts. So you can say it's 3 groups of A equals 180. And doing exactly what Losalia had said, it's 180 divided by 3 because you're sharing them equally to figure out how much each piece would be. So what's a third of 180? Well, 180 divided by 3, that equals 60. Very good. So A must be 60 degrees. Similarly with part C, or technically that should have been B. How do we do B? So we've got 2 A's, 2 equal parts of A. So if I add these 2 together, I get this angle. What's so special about this angle that I just colored in? William. Beautiful. 70, and this angle on this side is vertically opposite. So that means A plus A had to equal to 70. Because if that's 70, and then the entire side over here has to be 70 as well, well, now you've got 2 of them. So if I had to share it to 2 groups, 70 divided by 2, well, you can think of it as double of whatever A is meant to equal to 70. And 70 divided by 2, what's half of 70? 35. So A must be 35 degrees. Well done. Now, the last one, it looks complicated, but it's actually following the same idea. They just didn't draw the parts for you. So instead of doing A and A, they can write 2A. So that's what they've done here. Instead of splitting it up and saying this is A and this is A, and then splitting this up into A, they're combining it together and saying A and A makes 2A. Instead of splitting this up into 3 and say that's A, and A, they're calling it 3A. But if you think about it, if you've got 2 A's here and then you've got 3 parts A here, what's the total number of A's in this arc? 5. Very good. So there should be 5 A's. So 2A plus 3A should give you a total of 5 A's. So that must mean there's 5 equal parts. If you have to visualize it, it looks like this. This is 1A, 2 A's. Here's another 3 A's, 4 A's, 5 A's. There we go. There's 3 here and then there's 2 there. So if you count them, 1, 2, 3, 4, 5. But if you look at the angle, that's a straight line. So the total angle must be 180. So that means 5 of these A's is meant to equal to 180 degrees. So if you want to know what each A is, find a fifth of it. 180 divided by 5. Now who's got some quick maths? What's 1?
36.
Is it 36? Let's see. 3. Yes, you're right. 36 degrees. Fill that in. So this is the kind of problem you're working in exercise 2A. If you're doing the fluency part, you should be able to finish within this session today. There is one question that I had so many students ask while they were in class for the other class for 2A. I'm going to show you the question, and let's see how many of you understand what the question's asking, okay? So I'm going to flip over. Here we go. So in the exercise, the most frequent question that I had was this question. Question 3. It says, for the angles in this diagram, name an angle that is. Now, what does this symbol mean? Hands up if you know what that symbol means. Holly.
Acute. No, it's
Not acute, but I know it looks like an acute. It's not acute. Means angle. So write that in if you didn't know, or draw it on your own notes. That symbol there means angle. Then they say AOB. AOB tells you where in this diagram is your angle. So if you follow exactly what they said A. So here I go. I start at A. And they say O, which is over here. So I draw it. So A to O. And then it says go to B. There we go. That little angle there that I'm drawing, that's AOB. So now they're asking, name the angle that is vertically opposite to AOB. So the angle AOB, which is between A and B, that angle, what is it vertically opposite to?
DOE.
Yeah, DOE, or between D and E. This is vertically opposite. These two angles, let me color it in again. This angle and this angle, these two are vertically opposite. But how do you name it? You use the symbol, angle, and you can do DOE, or what's another way? So you can write angle DOE to draw that angle here. So DOE. What's another way of writing it? EOD. You could also write angle EOD, and it will be the same one, because you're starting at E, you go to O, go back to D, you create that little angle there. Okay, so that angle, the answer for that question could be DOE or angle AOD. And that's being vertically opposite. Does that make sense? Okay, so this question is now asking complementary. What's complementary mean again? Right angle, so it adds up to 90. Okay, so now it's saying BOC. So if I rub all this off, let's look at where BOC is. So here we go. B starts here, O is here, and C is here. So this is the angle I'm looking at. Which other angle will make it add to 90? Losalia. Yeah, it's between this bit. This angle and this angle, so between A and B, and then B and C, these two should add up to 90 degrees, so hence it's complementary. So how do I answer the question? I'd say angle AOB, or you could have wrote BOA. Doesn't matter. I did the first two for you. I'm going to leave C and D for you to do, but that was the most common question I had students ask because they weren't sure what it was asking. Okay, that's it for today, team. And let's stop the video, and it is your time.